Estimation techniques. The basis behind estimating the time requirement for work to be completed is a correlation between the number of man-hours required and the number of staff available for the task. There are two methods of estimating man-hours required for a work item. One method estimates the overall man-hours and the other estimates the man-hours required for individual work items and adds their sum to calculate the overall man-hours required. Another method estimates the scale of the work based on lines of code or amount of data, which is then correlated with work productivity data to calculate the number of man-hours required for completion. The scale of the work, which acts as a basis for this calculation, is often estimated based on experience gained from similar projects in the past, but there are several methods to do this. One. Analogous estimating. Analogous reasoning estimation is a method that makes an estimate based on all the experience gained from similar system development projects completed in the past. Generally, in estimates prior to a project launch, it is necessary to quickly grasp a rough budget estimate. Thus, when time constraints make detailed analyses unavailable, this is a commonly used method of estimation. Analogous estimate is less costly than other techniques, but less accurate. Where project members have significant experience or experts are available to make these estimates, higher level of reliability can be expected. Two. 3-point estimates. In 3-point estimation, the most probable value, standard value, mode value, as well as the maximum value, worst case, and minimum value, best case, are determined, and the average of these three values is used to make an estimate. Here, there are two methods of making the 3-point estimate. One takes the simple average of these three previously estimated values. The other multiplies each of these three values by a fixed coefficient and then takes the weighted average of those values. Using this method, one can calculate the number of man-hours necessary to complete work by a single individual, then use this estimate to calculate the total work hours for an entire project team. This method is very useful for calculating the total work estimate for projects in which the work is the collective result of individual activities. With basic data of this nature available, imbalances between individual jobs can be observed and a more scientific risk management approach can be applied to the overall work schedule. 3. Top-down estimating. The top-down estimate is a method that first calculates the overall scale, amount of development, then allocates a required development value to each individual work item. This method is frequently applied in situations similar to those explained in analogical reasoning method. In addition, when an overall budget limitation exists prior to the project planning stage, the top-down method is often applied by dividing up and allocating this total amount to individual work items. 4. Bottom-up estimating. The bottom-up estimate is a method that examines first the work scale and required man-hours for each individual work unit indicated in the WBS and then totals all of these values. This method is also called the standard value method because it uses a standard value of productivity based on past experience to estimate the number of man-hours required. Other methods are the LOC, lines of code, method that uses the number of lines of code as a basis, or the Putnam and Kakomo, constructive cost model, methods that place importance on past data. Five, FP, function point, method. This is one of the order of magnitude estimates that performs a statistical estimate based on past cost data or other such previously acquired data. A complexity value is added to the number of screens, the number of files, or other such data, and a function point is calculated. Then, an empirical formula based on past results is used to make the final estimate. Specifically, an estimate is made in the following steps. A. Function value, FC value. Focus is placed on 5 user function types, number of external inputs, number of external outputs, number of logical internal files, number of external interface files, and number of external references. A 3-level complexity evaluation is performed. A weighting coefficient multiplied to those values, and then those values are added together to obtain the FC value. B. Degree of incidence, PC value, and process complexity, PCA value. 14 system characteristics are evaluated to calculate the PC value, from which the PCA value can also be calculated. C. Function point value, FP value. The FP value is obtained by multiplying the FC value with the PCA value. D. Scale estimate value. The FP value can be converted into required man-hours, scale, by using past performance experience that is appropriate for that particular FP value. Cost planning and control. Budget results management. In a project, cost must be managed quantitatively. To manage costs, it is important to analyze the variance between the values detailed in the budget plan and the values of actual costs. This type of management, comparing the budget, plan value, and results value, is called budget results management. In progress management, the focus is variation in man-hours. There are 2 possible elements which can lead to a variation in planned man-hours and actual work hours. One of these is an increase in scale, added specifications, etc. And the other is a decrease in productivity. The expected standard in the initial estimation stages is not being met. In project management, meeting the delivery date for the final product, the ultimate goal of the project, as well as the function, quality, and performance standards are all extremely important. However, it is equally important to perform careful cost control, reduce costs, and complete the project within the established budget. Therefore, it is important for both the project manager and for project members that sufficient attention is paid to cost.